Morning, everyone. Now right here I've got a circuit to test the switch mode power supply controller IC, part number UC3844. Now a bunch of different manufacturers make this: Fairchild, Motorola, Texas Instruments I believe makes it also. So you'll find many different manufacturers of this IC. This IC is used in power supplies, switch mode power supplies, and we're going to test it. At the end of the video, when I get to the house, I'll show you the diagram. It came from the Fairchild data sheet. Let me put it up real quick. See if I can hold it steady in front of the camera there. That's the circuit, and this is from the Fairchild data sheet. So if you can find that, you can breadboard that circuit right there. It's got all the part, resistance, capacitance values of the transistor value, potentiometer values. That's a neat little circuit right there that somebody put together. I'll talk about it when we get to the house. Right now, let's look at the waveforms over there. There's two potentiometers on this circuit. Get my glasses on so I can see what I'm doing. This potentiometer is for the voltage feedback, and that goes into pin 2. This potentiometer over here is for the current feedback, and the current feedback pin is on pin 3. That's your current sense pin. And we'll look at a few other pins here in just a little bit. But right now, watch what happens when I increase the voltage to the voltage feedback pin. Look at that. And we have no more PWM right there. Yeah, we're at ground. Now let me decrease the voltage. And the pulse width modulation increases. Same with the current sense. When I increase the current sense voltage, the pulse width modulation decreases. There we're at 0. It's turned off. When I decrease the voltage, the pulse width modulation increases. Isn't that amazing? Let's go look at a few more pins. I'm going to move the camera to the front of the oscilloscope so y'all get a better idea of what's going on here. Give me a minute to move the camera. Now what we're looking at right here, this is the output of that switch mode power supply IC. That's on pin 6 for this 8-pin DIP package, dual inline package. Pin 6 is the output. I'm going to increase the voltage to the voltage feedback pin. And there, the PWM disappears. I decrease that voltage, and the pulse width modulation is at max. Now here's the current sense input on pin 3. When I increase the voltage there, the pulse width modulation goes to ground, 0. Now I decrease that voltage on pin 3, and we max the pulse width modulation out. Notice that it never goes to 100%. If it went to 100%, the switching MOSFET would be turned on all the time, and we would exceed the maximum allowable current through that switching MOSFET. We would destroy it. So be careful there. You don't ever want to turn it on all the time, and this IC prevents you from turning it on all the time. It cannot do it. Let's go look at a few more pins that are very important here. there's pin 4, that's called the RT-CT pin. When this IC is up and running, when it's producing PWM on the output, you should see a sawtooth on pin 4. Let's go over and look at it. Okay, let me increase the amplitude here. There's our sawtooth. The sawtooth is used as the reference to create the pulse width modulation. Another pin that's important is the VREF pin. This is a precision, let me go look at it, move my scope over here. This is a precision 5 volts output. Let's get back to 5 volts per division. That's used in the circuitry, the external circuitry of this switch mode power supply controller. For instance, that RT-CT pin has a resistor that's tied to this reference voltage. The other side of the resistor goes to a capacitor that's grounded, and between the resistor and the capacitor is connected to pin 4, the RT-CT pin. So this reference is used in that RC network that creates that sawtooth. Let's look at pin 7. Pin 7 is the VN pin. Get my amplitude down here. Right there is 10 volts per division. The VC pin, pin 7, has a parameter called under voltage lockout. This IC will not start up, it will not start to switch its output until that threshold is met or exceeded. I'm going to reduce the voltage on this power supply while we look at the output, and I'll show you what we're talking about. Let me move back to the output there. And this one right here, that threshold voltage is 16 volts DC. I'll show you how that works. Let's fire this up, and I'm going to increase this voltage on the power supply, pin 7, the VC pin, and its ground on pin 5 until we start up. There's 5 volts. There's 10 volts. There's 15. Almost there. There we go. There's 16 volts right there, and we've started up. That ensures that we have a good VC to ground voltage before we start running. There we go. We've looked at all the important pins on that IC. When I get back to the house, we'll talk about this circuit. Okay, we'll see you in a little bit. Afternoon all. We've made it to the house. Now here we're going to talk about the circuit that we had breadboarded this morning to test the UC3844 switch mode power supply control IC. Now here on pin 7 and pin 5 ground, we applied a 16 volts DC from an external power supply. That 16 volts being above the under voltage lockout threshold. Once we made it past that under voltage lockout threshold, this IC started to switch on the output, pin 6, that would drive into the gate of a power MOSFET or the base of a power transistor. Up here on pin 8, we have a precision 5 volts output, and that's used by the external circuitry of this UC3844. Now over here on pin 4, that's the RTCT input. That's an oscillator input, and it requires a resistor and a capacitor to create the sawtooth that we saw here at pin 4. The resistor is tied to that 5 volts out from the VREF pin and connected to pin 4 on the other side. The capacitor is also connected to pin 4, and its other side goes to power supply ground. Over here on pin 2 is the voltage feedback pin, and we use a voltage divider here with this potentiometer and two 4.7 kilo ohm resistors to raise and lower that voltage at pin 2. Pin 1, internal to this IC, there's an operational amplifier, and pin 2 is connected to that operational amplifier inside there. The output of the operational amplifier is fed back to pin 1. And here we have a 100 kilo ohm resistor in the feedback to close that loop of that operational amplifier. On this wing of the voltage feedback potentiometer, we have a 4.7 kilo ohm resistor, and that's tied up to that 5 volts on the VREF pin. On the other side of the potentiometer, there's another 4.7 kilo ohm resistor, and that goes to bus ground. The potentiometer is 1 kilo ohms, and its wipers fed into pin 2. Now here, this gets a little bit interesting with this 2N2222 NPN transistor. On the wing of this 5 kilo ohm potentiometer, its emitter is connected to the wing of that 5 kilo ohm potentiometer. The other side of the potentiometer is connected to power supply ground. The collector of this NPN transistor is also tied back to the 5 volts out of that VREF pin. Now what's going on here? With the base connected to the RTCT RC network, we have the sawtooth on pin 4. That same sawtooth is fed into the base of this NPN transistor. So here we have a variable sawtooth that we can increase in amplitude or decrease in amplitude with that potentiometer that fed back into the current sense input on pin 3. That sawtooth, that variable sawtooth on pin 3, simulates the current sense feedback of the switching circuit. Now I'll put up a schematic diagram, and I'll show you what is required, what we usually see on the current sense feedback. And this circuit right here simulates that feedback, that current sense feedback. Give me a little bit to put that other diagram up, and at the end of the video I'll put this diagram up so that you can take a snapshot of it, a screenshot of it, and duplicate it so that you can experiment with this UC3844. It's a nice circuit that you can use to test that IC outside the real power supply. that it usually sits in. Now here's a schematic drawing of a real power supply from the Motorola datasheet. That last schematic that we had there, that came from the Fairchild datasheet. And I want to show you the output driving into this power MOSFET right here. Here's pin 6, the output of that UC3844. It's in this dashed box right here is the internals of the IC, a simplified diagram. The output is on pin 6. That drives into the gate of the power MOSFET through this 22 ohm resistor. Now look down here in the source to bus ground of that power MOSFET. Here's the tiny resistor right here, 0.5 ohms. That's your current sense resistor. It's very tiny. Between the source and that current sense resistor is fed back through a 1 kilo ohm resistor and fed into the current sense input of pin 3. And you can see that it runs back into this operational amplifier right here and goes to an SR latch, a flip-flop right there. Now, when the pulse width modulation is driving into the gate of that MOSFET, it's turning this MOSFET on and off. Up here is the DC bus. There's the primary winding at the drain of the power MOSFET, and it goes through to bus ground through that current sense resistor. Now this power MOSFET's turning off and on and off and on and off and on and off and on, and so you can see that across this resistor right here fed back into pin 3, it'd be pulsing off and on, off and on, off and on, and off and on. Very, very tiny, very, very tiny. But still, we had to simulate that back in this circuit right here. Let me put this circuit back up. We had to simulate that on-off, that very tiny on-off, into the current sense. And since we did not have the power MOSFET, the primary winding connected to the DC bus, the current sense resistor connected to bus ground, how could you simulate a little on-off voltage right here, on-off and amplitude right here at pin 3? Well, that's what this circuit right here does. That is genius. That is genius. Whoever thought of tapping off of that RC sawtooth right there and feeding it into the base of a transistor, that was very smart right there. Very intelligent people. So that's what this does. This simulates the current sense feedback. Now I used, on the breadboard, I used a 1 kilo ohm resistor for RT, and I used a 0.1 ceramic capacitor for CT to create that sawtooth on pin 4. There you go. Now this circuit right here, this will let you test that UC3844, the UC3842, and the other variants of the UC switch mode power supply controller IC. In the next video, we'll talk about that last schematic that I had up there that showed the real power supply. We could talk about a lot of things on that circuit right there. For instance, what usually goes bad, what causes it not to start up, and things I've seen in the past that you need to look at when troubleshooting these types of power supplies. Alright, we'll see you next time. Thank you very much for stopping by. I hope you're having a good day. Looks like we might get a little bit of rain later on. Good night, folks.